Hi there. So in this recording, we're going to get ourselves acquainted with task and the idea of task programming. So what is a task and why do you want to use it? Well, a task is just an abstraction. It's just .NET ways of grouping a unit of work together and telling the scheduler that this unit of work can be executed on a separate thread. So let's actually make some work for us to do. I'm going to make a static function called write, which is going to take a single character, let's go with C, and we're going to output it to the command line a certain number of times, let's say 1,000. So I'll take 1,000 times, and while I is going down to 0, I'm going to basically console.write this particular character. So this is my unit of work. This is what I want to be doing in separate threads. Now, in order to actually make a task, there are different ways of doing it. Now, the simplest way is to use the task factory. So in this case, we'll use task.factory.startNew. By the way, tasks, they live in the namespace using system threading tasks, so that's where they live. And when you start a task, you have to provide an action, and an action can be an anonymous function, or it can be an existing function, or it can be just a lambda. So basically, when you're starting up a task, you have to at least tell the task what it needs to do. In this case, we're going to write a single character. Let's write a dot 1,000 times. So that's one way of making a task. Now, there is a different way. The different way is to explicitly make an instance of the class task. So you say var t equals new task. And here, if you look at the constructor documentation, it's roughly the same thing. It just takes an action, basically. So you can once again provide a lambda. And here we're going to write a couple question marks. Okay, so there is a difference between task.factory.startNew and making a task like this. When you use start new, you're actually doing two things at the same time. You're making a task and then you're starting it. The difference is that when you declare a variable of type task, you're making a task, but you haven't started it yet. And to start it, you call t.start with a capital S, obviously. So this is how you would fire up the task t. So essentially, if you run this, then you'll get one thread started for writing dots, another thread for writing question marks. We may as well also write a bunch of characters on the main thread as well. So I'll write a bunch of dashes. Okay, so let's actually execute this and see what we get. As you can see, there is a nice mixture of dots, dashes, and question marks. None of them have priority. They are not grouped sequentially because essentially all three threads are executing at the same time. And because the command line in Windows is multi-thread compatible, you're basically having this kind of nice concurrent writing to the buffer. So this is a good illustration of how things run concurrently when you make tasks. And let's actually continue this idea of discussing how to customize the whole thing. So as you can see, the way we passed the arguments into the task was by making a lambda which takes no arguments, but then we specify the arguments explicitly. There's actually a different API that you can do, that you can use to actually provide arguments into the lambda. So it's a bit of a clumsy API, but let me show you how it works. Essentially, the idea is that your unit of work takes a single argument of type object. Not very convenient, I know. So let's have another function called write, which actually takes an object O, and then we'll do a similar thing to what we have here, meaning we're going to write things out 1,000 times, but instead of writing out the character, we'll just take the object and we'll implicitly call to string on it. So if you provide a string, you write that string. If you provide a number, you output that number. Hopefully you get the idea. So essentially what we can do is we can now use the same APIs that we had before. So for example, I can say task t equals new task. And if you look at the documentation, there are overloads here which take the action and they also take the state. So this is interesting because now what you can do is I can provide this write function, and in addition I can also provide some sort of argument to pass into the actual unit of work. So in this case I can say hello, for example. Okay, so that's one task. Obviously I have to start this task for it to actually work, and the same is available in task.factory.startNew. You can also provide arguments here. So in this case I can once again use the write function, but here I can provide 1, 2, 3 because that will also be turned into an object and will then be unpacked when it comes to actually writing it out to the command line. So let's run this. Let's see what we get in this case. So as you can see, we get a nice mixture of 123 and hello all over the place. So that once again illustrates that those things are running concurrently, and the fact that we're passing in the arguments. So that's okay. That's another way of passing the arguments into the units of work, although a bit clumsy because there is only one overload, and that overload specifies an object. And then, of course, as soon as you start boxing and unboxing things, it becomes computationally taxing, which, you know, it's really up to you how you want to organize it. But this is how you essentially make tasks with state. Okay, so next up, let's talk about how to return values from a function. So let's suppose that we want to have a unit of work actually calculating something. Let's suppose that maybe we want to calculate the number of characters in the textual representation of whatever object got passed in. So in this case, I'll write another function. So we'll have a function which returns an int, let's call it text length. And this function is going to take an object, O, and it's simply going to return o.toString.length. So it turns it into a string and returns the length. However, we might want to have some debugging output here, and that's good for us to figure out which task we're actually in, and for that the task can actually give us its ID. So let's have console.writeLine, and what I'm going to write here is the following. So let's do a line break, and let's say the task with ID, and then use the task ID. So we can say task.currentID. That gives us the ID of the currently executing task, meaning the task that we're actually in. So task.currentID is currently processing the object O that we've specified, like so. So I'm going to write line this, and then I'm going to return the actual length. Okay, so we now have this unit of work. Let's try actually using it. So the API is very similar to what we have here, but not quite, because now we're going to use generic versions of task and indeed generic versions of start new, because we need to specify the type of the return argument. So here is what it's going to look like. I'm going to make two pieces of text. Let's suppose we're going to measure text. So I'll have text1 equals testing like so, and I'll have text2 equals this. So they have different lengths, 7 characters and 4 characters. So let's make a task. I'll make a task1, new task, but notice that the task has an overload with a generic argument tResult. That's exactly what we're going to use now, because our unit of work has a return of type int. So we'll make a task of int, and here we specify the name of the task, so in this case text length, and we also specify the actual argument, in this case text1. So we're calling this function on a separate thread. It's going to take text1, measure its length, return it to us, but it's also going to do this nice write line thing for us. So task1, since it's an explicit task, it has to be started, so task1.start, and then we'll make a second task using task.factory.startNew. Once again, we'll use a generic version of start new by specifying an int here, specifying the text length as well as text2. And what I'm going to do is I'm actually going to save this, because remember, when you call start new, it also returns a task, or specifically a task of int in our case. So I can say task of int task2 equals task.factory.startNew. You'll notice that the type argument really is redundant, because unlike constructors, the arguments of these generic arguments, they can be inferred. In this case, I can simply get rid of it. You cannot get rid of it in the constructor yet. Maybe .NET will implement this someday, but you can get rid of it in function calls, so we'll have that. So now I have task1 and task2, and what I can do is I can write out their result. Now, as soon as you ask a task for its result, you're basically saying that you're prepared to wait until the task is finished, which means that getting the result of a task is a blocking operation. It will basically block until the task is complete, and when it's complete, then it's going to give you the result. So let's output the results of both of these invocations. So I'll console write line, and here I'm going to say that the length of text1, in this case, is, and I'm going to get it from task1.result. That's how you get the length. And I'll copy this, copy the entire line, in fact, and I'll have the length of text2 being task2.result. There we go. Okay, so let's actually run this and see what we get. So as you can see, we have the output from the tasks themselves. Remember, we added that write line in there. So task with ID 1 is processing the object testing, task with ID 2 processing the object this, and when you ask for the results, that's when you wait for the task to complete, and you get the length of testing being 7, the length of this being equal to 4. So that's how you essentially pass the values into the tasks, as well as how you can actually get results out of the tasks.